Alright, so first video of the set. So this here is an example of a grid. This is actually a past paper question from one of the assignments. So you can just see like a full setup of how the questions will come. So that's a run through it. On top here, you have your generators, so the generating the powers. And on top here, you'll notice they give you the either gonna give you the megawatt or the MV as a rule of thumb. The generators must always be represented in its MVA format, not megawatt. So even if you see anything with megawatt, you have to convert it to MVA no matter what. So you have these. So they give you the per unit impedance, which we'll do now. I'll go through what that means now. Then they'll give you the bus. So the bus voltage is basically rated voltage of the bus. So there's a 11 kV bus, so the generator most likely producing 11 kV to go to this bus. And then the 11 kV is tapping off from onto two transmission lines to go onto two transformers, right? So if you look at this, the input of the transformer is 11 and the output is 69. So it's a step-up transformer on both sides. Then these two go into a 69 kV bus. And then after the 69 kV bus, you have two transmission lines. So most likely these are long transmission lines. So, and they give you the actual impedance of it. And then that goes on to a 69 kV bus. And from the 69 kV bus, you have a bidirectional circuit breaker. So there's most likely the customer bus. So basically what this means is that if one line is to go down, you could always pull power from one line. Most of the time this open. And then you have two circuit breakers before it goes to your consumer, which is your loads. In this case, it had a fault here, but for now, we wouldn't be reaching the fault as yet. But for now, you can clearly see in this, the first problem, as you will notice, is that every single component is on a different MVA base. So the MVA base will basically determine the impedance and everything else that you will see. So in this setup, the generators for one are on different MVA bases. The transformers are on different MVA bases. And that's basically the only two things that are on different MVA bases. So the purpose of the per unit system is basically just to standardize the entire network. And once you standardize the entire network to one MVA base and one voltage base, it will make calculations easier because basic ratios you'll be dealing with. So 50 MVA will always be 5, no matter where you are on the network. It just basically makes calculations easier because if you operate everything at different MVA bases, if you were to change something here, you have to do for the calculation for here and everywhere else on the network. And you don't really have time to do all that. So because you don't have time to do all that, the easier thing to do would just be to standardize the network. And standardizing network just basically means choose a MVA base and a voltage base and get all the impedances to that set base. And once all the impedances are raised to that set base, it will make all calculations easier. So the purpose of the per unit system is to get everything to one base in the network to make further calculations easier to do. So for the generator, they will give you the per unit impedances as percentages. We just convert it to the decimal form. And those per unit impedances are represented at the particular MVA base of the generator right now. So first off, this will have to change to MVA. So I'll go through a video where I do the calculations with. But for now, just to understand. So these two have to change to MV, and when it changes to MV, you'll notice that all four generators will be at a different MVA base. So in the exam, they will give you an MVA base. If not, you can just choose an MVA base. and you'll have to raise each MVA base, each generator to that MVA base. Alright, and by doing that, the per unit impedance will change with respect to the new MVA base. And as an equation that you could use to do that calculation. So the first thing to look out for is generators in megawatts, and the other thing is raising everything to standardized MVA base. The other thing is the transformer. So you notice these two transformers are at 450, right? And at 450, the per unit is 40% or the 0.4, right? So according to what MVA base we choose, these impedances here may change. And the actual, so for the Z actual, it have a different equation that we use, but this is also specific to the MVA base that you choose. And well, everything else kind of stays the same in this system. So when you're doing per unit, the first thing you look for is your MVA base and your V base. The next thing you look for is to raise every component, in this case, transmission line impedances, generator impedances, and transformer impedances. Those are the four main components that you have to raise stuff to MVA bases. So let's go through some general equations that you have to remember, because if you don't, you'll struggle. So the first one is Z base. So normally this is the first thing that you should calculate, really. So this is basically an impedance base of the network, and the equation for it is kV base, so your voltage base in kilo. So a kilovolt base squared divided by MVA base. You will always know where MVA base is and your V base, because they are constants that are given to you or you choose. So once you know where your V base and your MVA base is, you can calculate your impedance base. The other equation you could use is the V base divided by root 3 of your I base. Alright, as we go through the equations, here just connect all the dots. So it's the first equation that you will have to use. Most of the time you need to calculate Z base. Alright? The other one is more of a general form of it. X means either Z, I, or V. Alright, according to whatever they want. And it's just the actual, which is basically as you look at when we look at here. So this is our actual impedance. These are per unit impedance. So if I wanted to calculate the actual and convert it to per unit, I'll have to use this one. So I'll have to divide the actual divided by the base. So if I wanted Z per unit, in this case to convert the actual, it would be Z actual over the Z base. And we know how to calculate the Z base because the Z base is KVB squared and MVA base. Alright, and same thing for I base, it would be I actual divided by I base, and so on and so forth. Alright, so base current, which is IB. So I base is KVA base, which you will know, divided by the KVB. So normally these two are cancelled, so it will just be your VA, which is this here, yeah, don't worry, so there's VA. So on the triangle, you have your Q, your P, and your S. So that will be a real power. And there's your quadruple, and there's your, so there's megawatts, sorry, apparent. Yeah, so there's your apparent power, there's your reactive, and this here is a real power. Apologies. So they will give you apparent. MV is basically apparent power, right? But in this case is K, so you have to convert it to kilo. So it'll be kVA base divided by your K kilovolt base. That'll give you I base. And the other one, the other two that are important. So we'll use this when you're trying to go from an old MVA base to a new one. The new one basically mean the standardized one. So the first one I think I'll show you all of this now. The per unit, if you want to convert the actual to a per unit, you divide it by the base. And then this one here will tell you what the per unit would be on a different base. So the Z per unit new would just be the old per unit multiplied by the new MVA base divided by the old MVA base. So basically the old multiplied by the new MVA divided by your old one. That will give you the new Z per unit. And well, the last one is some call it MVA short circuit. So there's something that will ask you to get. So the MVA short circuit is your V per unit multiplied by I short circuit per unit. This V per unit for this course is 1 all the time. So really you're just going to end up with your MVA short circuit per unit is basically the same as your I short circuit per unit. Yeah? And that's it. And then well, that is equal to 1 on your Z per unit. And well, one side note, the voltage magnitude and angle for your generator is normally 1 angle 0 as a standard. Right? So if you actually go back to the system now, if you choose an MVA base, this will be the equation that you're going from the old to the new. This will be the actual where you had to calculate the Z base and divide it. And these here will just be the same like I did before, the old going to the new MVA base. Right? And so the next video I'll do the calculations for it, but that is basically an introduction to the per unit system. We just use the standardize the network to one MVA base and voltage base to make calculations simpler. Alright, so I'll see you in the next one.